probability that they are not left-handed. Okay? 1 minus 0.15, which is equal to 0.85.
Well, you're not, but if they're ambidextrous, we consider that.
That's not left-handed, right?
Okay.
So I didn't write left-handed versus probability of right-handed.
Yeah.
I wrote probability of left-handed and probability of not left-handed. So I mean, this covers all possibilities. Whether it's a question, whether do we consider ambidextrous to be left-handed or not left-handed? I would say an ambidextrous person is not a left-handed person, right? Well, I don't know. That's what I would say. Right? If someone's ambidextrous, you wouldn't say that person's left-handed. You'd say they're ambidextrous. Okay, so in formula form, okay, so I put all of these, well, maybe I should just leave it like this and not give you the formula, because I have a feeling if I put the formula on here, you're going to write the formula on your note sheet and then confuse yourself later. Huh? But do you want me to do it? Well, I mean, is this easy enough to understand? If I say complement, you guys know what we're talking about here? Okay, then we're gonna move on. You'll see the formula in the book, okay? But we're not gonna do that then. Okay, let's say alright, what if I broke this up? What if I said the probability that someone is left-handed is equal to 0.15? The probability that someone is right-handed is equal to 0.84. So what is left? What's the probability of neither? Left or right-handed? So what percentage is left? 0.01. Okay. Everything has to add up to 1, right? Because if you're either left-handed or right-handed or something else. Okay? That's it. There's no other possibilities. You're either left-handed, right-handed, or something else. Okay? Whether it's ambidextrous or just, you know, you have no, I mean, no hands or something, right? I mean, that's for real. So that's it, okay? Everything must add up to 1. So if you add up all possible outcomes, it must add to 1. Okay? So be careful in case some outcomes overlap. Right?
Would you say that's the definition of the complement?
I'm sorry?
Is that kind of the definition or the summary of the complement?
The summary of the complement is that one thing and its complement must add to 1. Okay? These aren't technically, they're not really complements here.
So do you have a concrete definition for the complement, or it's just fallback?
No. The complement is the event that something doesn't happen. Okay. The complement of an event is when the event does not happen. Okay? So let's just make sure we understand this question. A baby is born. If I say the probability that this baby is male, okay, or let's say the event is the baby is male, what's the complement of the baby being male?
Or not being that complement.
It's not female. It's the probability that the baby is not a male. Okay? Okay? It's I mean, in our way of thinking, we think either babies are male or female. But if the way the complement is defined is not male or female, it's the baby is male versus not male. Okay? Now, most babies that aren't male are female, but sometimes there's, you know, ambiguous gender babies, and that happens, you know? Okay, so what's the if one event is a person has black hair, what's the complement? Not have black hair, okay? If the event is tomorrow is Thursday, what's the complement?
Tomorrow is
Not Thursday, okay? That's it, all right? I mean, we give it this not a complicated name, but we give it this unfamiliar name because I don't know what else you could call it. Not the non-event or something, I don't know. The opposite day event, whatever, okay?
I don't have this up here, but you're supposed to familiar with like complementary angles.
Complementary angles mean they add up to 90 degrees, right? So I mean, it completes the right angle, I guess. I don't know. Huh?
Like, I mean, if it's the right to try to make it
Yeah, I don't know. I don't know if I like. It's probably. I mean, that's where they use the name, but this is probability, not geometry. Okay, we got more stuff to talk about. Okay, so let's talk about the word and. Okay. Let's say make a table. Alright, so let's say we've simplified the world and we've just said, you know, people are either male or female, okay? And then no, sorry. Let me change this on you guys. I apologize. I just have to make this a little bit. Yeah, there's another row here. Okay, so let's say you go to a clothing store, okay? And they've got different T-shirts on sale. All right, and whatever. This is you can either get this shirt in small, medium, or large, and you can get the shirt in either red, white, or blue. Okay. But let's say you know, red has been more popular, so the stock is a little bit lower, and there's 60 shirts left, and blue there's 100 shirts left, and white there's 140. So how many shirts total are there? 300. Okay. And let's say you know, the different sizes. So let's say there's 150 large shirts and 80 medium shirts, 70 small shirts. Okay, I haven't filled out the inside yet. So, but let's see if we just understand what we're doing here. If I ask you, if I'm going to draw a random shirt, what's the probability that this shirt is red? Okay, 60 out of 300, and that's equal to 0.2. Okay, what's the probability that it is not blue? Okay, 200 out of 300, 0.667. Okay, or I could have done, this is equal, so another way is I could do 1 minus the probability of blue, 1 minus 100 out of 300, 1 minus 0.333. Okay. These two things are exactly equivalent. Alright, so if I said, what's the probability that a shirt is red and blue? What's the probability that a shirt is red and blue? 0. Can a shirt be red and blue?
No.
No. So why are you guys telling me all these other numbers?
Oh,
Okay? You're either going to get a red shirt, a white shirt, or a blue shirt. Okay? So the probability that a shirt is red and blue is 0. Okay. Huh?
Wait, how about if you're like trying to buy a red shirt and a blue shirt? Or like is that?
That's, I'm not. We didn't even talk about buying shirts. I just said
Oh.
I've got a stack.
Oh,
I've got a
okay,
stack of
okay,
300
yeah.
shirts, and I'm just picking one at random.
Oh, okay, all right. never
Okay.
mind.
If I pick a shirt at random, what's the probability that this shirt is going to be red and blue? 0. There's no chance. Okay. What if I ask, what's the probability that a shirt is red or blue?
Okay, that's
160 is 300.
This is what?
160 is 300.
160 over 300. Okay, that's something else. I don't know what the answer is. Is that okay? 0.5333. Okay. Let me put in some extra numbers here. Huh? No, this doesn't add up. 50. Okay. What if I said, what's the probability that a shirt is red and small?
Sign out 300.
10 out of 300. Why? I'm asking, there's 300 shirts here, okay? 10 of them are small red shirts. So if I pick one at random, what's the probability that I'm gonna get a shirt that's red and small, or basically a small red shirt? There's only 10 out of 300. Okay? So that's like 0.0333. Is that okay?
Yeah.
What's the probability that I get a shirt that's white and large? Okay, so probability of white, a shirt that's white and large, 70 out of 300. Yeah, 23.3%, 3.2333. Okay, let's change this up. What's the probability that I get a shirt that's red or small? Red or small. So what does this mean? Remember, imagine I've got 300 shirts here. Okay. How many red shirts are there?
60.
Okay, how many shirts are red or small?
130.
There's 120 shirts total that are red or small. How do I know that there's 120? Huh?
60 plus 130.
Let's take a look. Let's take a look. All right.
Oh, because those are kind of
Red small shirts. Are they red or small? Do these qualify? Someone says, your friend sends you to the store and says, get me a shirt. It's either got to be red or small or both, okay? So does this qualify?
Yes.
All right. Does this qualify?
Yes.
Does this qualify?
Yes.
Yes. Does this qualify? Yeah, because it's small, even though it's white. What about this one?
No.
This one?
No.
Okay. This?
Yes.
What about this?
No.
And this? No. Okay. So let's look at all those shirts that qualify. 30, 30, 10, 20, 30. Right? So total shirts that qualify, I got 30 plus 30 plus 10 plus 20 plus 30. That equals 120. How many shirts total do I have? 300. 300. So that's equal to 0.4. Does that work?
Yeah.
Okay. What if I said there's another way to get this answer, okay? So sometimes if we have the table like this, we can figure this out. But here's another way we can figure it out. All right? I could say, how many red shirts are there? There's 60 red shirts, okay? How many small shirts are there? 70. Okay? So I'm counting all the red shirts, and I'm going to count all the small shirts. Okay. But I'm getting 130. Why am I getting 130?
You counted twice on the ones that are red and small.
I'm double counting the red small shirts, right? Because these shirts are counted when I say all the shirts that are red.